Alright, welcome back again, class. Today's lesson and the next lesson get a little tricky, so you gotta be paying close attention. Today will be rather straightforward. However, when you have this lesson and the next lesson to think about, you'll have to be very careful of what you're doing. And it'll make more sense a little bit today, but make more sense next lesson. So permutations, it says it is an arrangement of objects in which order is important. Order is important. Emphasis on order and important. You'll see the other one, order is not important. But for now, order important. Okay. So, I'm gonna go straight to... No, I won't. Okay. So, for example, what the book says, right? And example I'm gonna do so it makes sense. If you have the letters A, B, and C, right? I could have letters like that. I could have a CB. I could have BAC. I could have BCA. I could have CAB. Or I could have CBA. Right? I used to have the CBA building. Something business administration building. Right? So the order in this case makes a difference, right? Depending on what letter you have first, second, third, order matters. So I don't think that's a good example. There's another thing called factorial. Factorial uses the exclamation point mark, exclamation point, exclamation mark, I don't know which one. Okay. You will see it labeled as N exclamation point, exclamation mark, not sure still. And the typical way that they explain this is in a normal room, right? You have 4 walls, right? I can't draw a 3D very well, I'm not gonna try. So we'll just say wall 1, wall 2, or wall 3, and wall 4. Okay. And let's say I have, let's see, how many colors do I got? You have posters that you want to hang up, right? I have a green poster. I have an orange poster. I have a red poster. And I got me a blue poster. Right? 4 posters. I go up to my first wall. I'm like, which one do I put on there? I'm like, alright, I'll put the green one on this wall. Right? So, I used the green one. I looked at wall 2, right? I could have put, I'm gonna put a check mark because I used this one, right? But I could have chose from any of these options, right? But I finally put on the poster tape or hung up, however, that green one. I go over to wall 2, I'm like, got the green one here. Which one do I want to put here? Let's see. I could either put the orange one, I could put the red one, or I could put the blue one, right? I can't put the green one because I already put the green one here. So I'm gonna do the orange one, right? I go over to the third wall. I'm like, I got the green one, I got the orange one. What do I want here? Do I want the red one? Or do I want the blue one? I'm like, oh, the orange is here. I'm like, I think the red one's what I want here. And the fourth wall, if you're smart, hopefully there's not too much thinking because you're like, I only got one left. It's got to be the blue one, right? So if you look with my options, I had 4 options for my first wall. Then I had 3 options. I had 2 options, and then I had 1 option left. Okay? So I had 4 options, 3 options, 2 options, 1 option. When you go down one at a time, 4, 3, 2, 1, all the way down from some number to 1, going like 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, as a factorial. So this would be 4 factorial, which means you're going to do, and you'll see, I don't know how well it'll show, but 4 times 3 times 2 times 1, let's see, it's, well, 24. However, there's also a button on your calculator. So, do you see this PRB button? It's the probability button. You'll see there's an NPR, NCR, and exclamation point. So, if I put 4 PRB, exclamation point, enter, I also get 24. Because this means do 4 times 3 times 2 times 1. If you had 5 exclamation point, right? That would be 5 times 4 times 3 times 2 times 1, okay? We don't have that one though. So, whenever you come to a circumstance where you realize it goes down 1 at a time, you're gonna use factorial, alright? And this will make more sense in a second. Got loose marker lids everywhere. So, that's my example. Spoiler. Permutations. You're gonna see that there's the P button on the calculator for permutations, which is 5 factorial. Oops. Let's take a step back there. There's the P button on the calculator. You guys saw that. And PR. Calculation wise, again, you're gonna use the calculator, so it doesn't really matter. But it's n factorial, and then n minus r factorial. So let's do an example and kind of see what this is all about. You're at a science fair. The at sign is one of my favorite symbols to write. You're at a science fair, and there's prizes, the first, second, and third. So first, second, third get prizes, right? In the science fair, there are 10 contestants. This is not, and everyone gets a participation prize. There's a winner, and there's a second place, a third place, a fourth, fifth, sixth, seventh, eighth, ninth, 10th place, okay? So, their question, find how many ways the prizes could be distributed. Now, I'm not going to bore you with what the N and what the R stands for or represents. I will explain what goes where. Okay? So, the N is how many total things do I have to choose from. I have 10 people that I need to award 3 prizes to, right? And it matters if you're first, second, or third. I'd much rather be first than third. let alone 10th place, okay? So, however many you have to choose from goes first. You then have the P, okay? P means order matters. That's what you need to remember. P, order matters. And then this R is how many things do I have to choose to give away from. Like when you had the 4 walls, you had 4 walls, okay? So there's 3 prizes to be given away. In the calculator, you'll just type in 10, then do the PRB button, NPR button, what did I say? And then 3. And you will see it spits out 720. There are 720 combinations. That's a lot. 720 combos. Can I get a combo with fries? Extra large, please. Okay. If you don't have a calculator and you're like, I don't know why you wouldn't use a calculator, but, right? N is 10 over 10 minus 3 exclamation point. So that's 10 exclamation point times 7 exclamation point. Now check this out. That means this is 10 times 9 times 8 times 7, 6, 5, 4, 3, 2, 1, right? 7 exclamation point is 7 times 6 times 5 times 4 times 3 times 2 times 1, right? Do you see how there's like 7, 7, 6, 6, 5, 5? There'll be a 4, 4, 3, 3, 2, 2, 1, 1. All cancel. So basically you're going to have 10 times 9 times 8. And if you did that, 10 times 9 times 8, you see you get 720. But you're not going to do that because just type in the calculator. You'll do 10, P button, 3. Boom. Okay? If that didn't make sense, and it probably didn't, hopefully this next example helps. This is number 8 in your book. It says you have a lock. The little locker code locks for the thing. They have to type in, you like go spin it, overlap it, and then spin it back, and then okay. You forget your locker code, right? You know that there's a 4, a 22, and an 8. Okay, you know that it's those 3 numbers, but you forget, is it 4, 22, 8? Is it 22, 4, 8? Is it 8, 22, 4? You don't remember, you just know that those are my 3 numbers, but I had no idea what order they're in. So, the question is, what is the probability you get the code right on the first guess? The code right on first try. Right? Well, let's see. This is where it's a little tricky. Okay, so remember my NPR thing, right? Order matters, obviously, right? If you don't do the code in the right order, it ain't gonna open, right? Right. So, there's 3 letters, right? So it's a little bit weird. There's 3 letters, and I need to pick all 3, right? I need all 3 of them. So, if you do 3 P 3, see there's a 6 right there. It equals 6. So there's 6 different combinations. And you'd be like, are there 6? Yes, there are. It could be 4, 22, 8. It could be 4, 8, 22. It could be 22, 4, 8. It could be 22, 8, 4. Could be 8, 4, 22. Could be 8, 22, 4. Can you think of any other combinations it could be of those 3 numbers? No. It's one of these. So there's, as our math showed us, 6 combos. Okay? How many combos work of these 6 combos. There's one combo. One works. So the probability of you getting the one that works out of 6 total is 1/6. Pretty good, right? This example makes sense, right? I think this one makes sense. Let that sink in. 6 combos. One of them works. The probability I get it right of one working out of 6 total is 1/6. That's basically how those ones are solved. So I hope that made a little bit of sense. Another long video. Dang, I hate editing these long videos. I need to stop doing that. Alright, I'll catch you in the next one.